want to go over a problem from one of the sets in the past. It was the function composition, inverse function section. Page 110, number 16. It had a couple algebraic techniques that you're familiar with, but you may be a little rusty on. This asks you to find, we're just doing part of this problem, f of g of x, and then g of x. We're just doing this part, where f of x equals x over 2 plus x, and g of x equals 2x over 1 minus x. So we want to compose these functions. Most people set this up right, which is a huge part of the battle. So you take f of x, and wherever you see x, you put in g of x. So this means we take f of x, we want x over 2 plus x, but wherever we see x, we put in 2 plus x over 2. I'm going to write that in blue. 2x over 1 minus x all over 1 minus, and then we put in x. Oops, sorry. We're doing f of x, which is x over 2 plus x. On the bottom here we have 2 plus, we see x again, so we put in g of x to get f of g of x. I guess we're doing this all in 2x over 1 minus x. This is a huge stack of things. It's horrible looking. So we want to solve this for x. Several people, and it's not unreasonable to think maybe you can do this, just went in and canceled these two out. They say these two factor out, eh? So I can just cancel them. I canceled this, and well, you can't do that. That is not fair. And the reason you can't do that is you can cancel out factors in the top and bottom, but this is not a factor. This whole thing is a factor. So you're canceling part of a factor. And you can't do that. So you're like, well, I don't remember all these rules. I'll teach you the method I use, which is to not remember anything early on. And just see if it sounds reasonable what you're doing. Say you had 3 over 4 plus 3. Say you had that. Well, you can look at that and say that's 3 over 7. Is it fair to say cancel out these 3's and maybe you're left with 1? I don't know. Some people did different things. Is this equal to 1 over 4 or even 1 over 5? Well, no, it's not. This is 2. This is 3 over 7, which doesn't simplify, and it's not equal to any of these. So it's my suggestion is if you're in a test or something, you forget this, which is happens more often than we'd like to think. Go ahead and go back and try simple numbers in, see if it works out. If you thought maybe you could cancel these things off, after you try this, you can see, well, that's definitely not the case. Alright? So, that's not how you solve the problem, and that's mainly what I wanted to show you today. How do you solve the problem? And I'm going to back up here because I'm too lazy to rewrite the whole thing again. So starting with this setup again, what do you actually do? Well, one thing that is fair is you can multiply. There's several ways to solve this. One thing you can do is multiply top and bottom by the same thing. And you say, oh, there's a 1 minus x in the bottom, 1 minus x in the bottom here. If I could get it so everything was over 1 minus x, I could cancel those out by multiplying top and bottom by 1 minus x. First I have to get this so it's over 1 minus x. So what you do here, one way to do this, is you rewrite the whole thing on the top part. You don't change anything. We're going to change this 2 and multiply it top and bottom, just this 2. It is fair to multiply a number top and bottom, even within a big expression. And you can always try this. I mean, if you have 3, is that equal to 3 times 2 over 2? Yes, 3 is equal to 6 over 2, which is equal to 3. That's fair. That's completely fair. But you have to do it to the top and bottom. So these are all the operations you learned before, and maybe you're a little rusty on. So this, I'll write in the intermediate steps. This is 2, 1 minus x, over 1 minus x, plus 2x over 1 minus x. Now these two things have the same denominator, we can combine them. 2x, 1 minus x. And we can multiply that 2 through, so we get 2 minus 2x plus 2x all over 1 minus x. Okay, now we're going to multiply top and bottom by, and this is just one way to do it. I know some people did it a different way. Top and bottom by 1 minus x. Now that these are one combined thing here, we couldn't cancel these here because of this 2. This 2 had to be over 1 minus x for us to cancel these out. Some people just look at it and you say, oh, you can cancel these two things out. That's fine too. Now we can see this simplifies to this. And if we want to go a little farther, we can see we have a plus 2x and a minus 2x here. These cancel. We're left with 2x over 2, which of course simplifies to x. So we were on our path to finding out if this is an inverse, and indeed it looks like it is so far. And in fact, I was trying to think of an example of an inverse where you get x one way and not x a different way, and I couldn't think of one. So maybe if you just go one way, that's enough. But never hurts to go both ways. If you mess this up, well, okay. So this is how you solve this. Just be careful not to cancel things out if they aren't factors. These two things are not factors. They look like they almost are. I mean, if this was times, then you could do that. If it was a completely different problem, times, you could cancel that out. Some other people flip and multiply. It's another technique we'll talk about later for this particular problem. Okay, so be careful canceling. Simplify things. You can do the same thing to top and bottom. You can do the same thing within a factor, and you get a nice solution out here. The other thing I was going to say is try numbers in. If you got, some people got, I don't know, if you did this wrong, maybe you thought this simplifies, I don't know, x over 2 plus x. You can always try in numbers. Try in something simple, maybe not 1, because this gives you minus 1 down here. Try in 2, find g of 2, and take that number and find f of that number, and see if you get the same number as what you think. You should get 2 out. If you don't get 2 out, and you got down here and you got 2 over 4, which is 1/2, and you're like, oh, maybe I made a mistake here. So just a little technique here. Try numbers in, and that'll help you. You really don't have to remember these algebra rules. They're all built into the numbers. You really know them. They're somewhere in your brain, and you can retrieve them. And they're logically, so if you can't retrieve them, you can invent them on the spot.